Objectives. Learning. 1. To identify the series circuits and parallel circuits with their components. 2. To understand and know the calculation of components in series and parallel circuits, I, V and R. 3. To apply Ohm's law, V equals IR. 4. To state the differences between series and parallel circuits and their components.
Welcome to Electric Circuit class. Hello, I am Faz. Dear students, does electric plays an important role in our daily life? Yes, we do. Just look around your house. We have television, kitchen appliances, vacuum cleaner, and much more. Electricity is important in our daily life since it helps us with cooking our appliances, for light to see at night in the dark, and for using laptops, microwave, satellite, antenna, the internet, and television. We use electricity every day to cook and clean with a vacuum. Hence, we cannot live without electricity. Guys, do you know what is the series circuit? Well, it is a circuit is said to be connected in series when the same current flows through all the components in the circuit. In such circuits, the current has only one path. Then, what is parallel circuit? A circuit is said to be parallel when the electric current has multiple paths to flow through. The components that are a part of the parallel circuits will have a constant voltage across all ends. So, this is an example of a series circuit. Just look at them. The bulbs are arranged side by side with each other as in this figure. Okay students, let's look at an example of a parallel circuit. Just look at the position of the bulb in this figure. The bulbs are arranged in 2 or more paths, and these paths are parallel to each other. Now, let us take a look on difference between series and parallel circuits. For A, it is a parallel circuit. In parallel circuit, the same terminals of both devices are connected together. Meanwhile, for B, it is a series circuit. Well, a series circuit is made by connecting the end of one device to the beginning of another. In conclusion, when the circuit is in series, the same amount of current flows through all the components. Meanwhile, when the circuit is in parallel, the current flowing through each component combines to form the current flow through the source. Okay students, that's all from me. Thank you. See you soon.
Alright, so now I will show you another alternative way for us to study or to learn about the parallel and the series circuit. So since we won't be in the school any sooner, so this is one of the best apps or website for you in building the circuit, the series and parallel circuit. So I'll show you how we want to build the series circuit. We need wire, of course, right here, and then we need to have a source. And then connect the wire. You have to elongate. And then what? We need bulb in order for me to show you the series circuit. So this is one of the example of series circuit, which is it has a one-way flows of current. Alright, I decided to add up. Oh no, I decided to add up more bulb. So if you want to rotate it, just press R in your keyboard and then connect the wire. So this is an example of series circuit, which it only has one way of current flows. Right. How about I add another bulb? Alright. So you press R. Okay, we move on to the parallel circuit. First, of course, we need the source. So the DC source is enough for you. This is just how to build lah. And then, alright, we need bulb. You could explore any element or component right down there. Right here, there are so many component and element which you can put in circuit. Okay, so connect it, and I decided, so this is still series circuit. Oops. Now I decided to put more bulb, another bulb here, and another bulb right here. So you connected it, right? Connected it. And then, ta-da! Okay, so yeah, rearrange them. So if you want to edit the parameters, such as the resistance, like 10 or 5, or yeah, you can do that. Just right click and edit parameters, and yeah, input your resistance, 10 ohm, 100 ohm. Yeah, you can edit it. So in this website also, you can calculate the voltage right here, or the ammeter, or the current flows. So in parallel, we have like so much current flow, like I1, I2, I3 right here. So this is why we call it parallel, right? So student, you can try it at your home. That is all from me. Thank you.
Hello everyone! Now it's Teacher Najah's turn. Now, let's learn about the potential difference in series and parallel circuit. Potential difference is the difference of electrical potential between 2 points in a circuit. It is from a higher potential to a lower potential. This is because current flows from a higher potential to a lower potential. Let's look at the potential difference in series circuit. When the circuit is connected in series, the total potential difference supplied to the circuit is the individual potential difference added together. Now, you can see that from the formula, the total potential difference, which is the V total, is equal to the sum of the individual potential added together. let's look at the potential difference in parallel circuit. When circuit is in parallel, the potential difference supplied to the circuit is the same for all components. Now from the formula and from the circuit, you could see that the V total is just the same with the other potential difference. Here's a side note for you. Voltmeter is an instrument used for measuring electrical potential difference between 2 points in an electric circuit. It must be connected in parallel. Alright, that is all from Teacher Najah. Now I'll pass you to Teacher Shazwina.
Hi everyone, I'm Teacher Shazwina, and now let's look at the resistance for per circuit. First, what is meaning of resistance? Resistance is a measure of the opposition to current flow in an electrical circuit. The effective resistance of a series connected bulb is higher than parallel circuit. This can be proved by the relationship with equation V equal to IR. The unit of resistance is ohm. The series resistance. From equation V total equal to V1 plus V2 plus V3, we can get IR total equal to IR1 plus IR2 plus IR3. Hence, the total of resistance is R total equal to R1 plus R2 plus R3. Next, parallel resistance. From equation V total equal to IR1 equal to IR2 equal to IR3, while equation current is I total equal to I1 plus I2 plus I3, we can know that I equal to V over R. By that, we can get V over R total is equal to V over R1 plus V over R2 plus V over R3. And if V is the same in this resistance, so we know the formula of effective resistance is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that's all about resistance. Now let's try to make an example of a question. Example question. How much ammeter reading if the voltage provided is 12 volt? Here we have multiple choice answer. A 0.5 ampere, B 0.4 ampere, C 1.2 ampere, and D 1.5 ampere. So let's do a calculation together. This question wants us to find the ammeter reading or current flow in this circuit. First, what we need to do, we need to calculate the total of parallel resistance. After that, we calculate the total of series resistance. And lastly, to find the ammeter reading or current flow, we need to use equation I equal to V over R total. So, after finish do the calculation, we can see that the answer for this question is 0.4 ampere. So, the answer is B. Wow, good job everyone. It's look like we are at the end of the video. Before the video ends, here is a summary for this topic. Thank you everyone for watching. That's all from us. See you again. Bye.